Nicotinamide mononucleotide, or NMN, has emerged as one of the most intriguing molecules in the field of longevity and metabolic health. As a direct precursor to NAD+, nicotinamide adenine dinucleotide, NMN plays a vital role in supporting cellular energy production and signaling pathways that maintain health during aging. One of the most promising aspects of NMN supplementation is its apparent ability to stimulate autophagy, the cell's built-in recycling and repair system, a process known to decline with age and implicated in the progression of age-related metabolic disorders. Aging is marked by a gradual decrease in NAD+ levels across various tissues, from muscle and liver to brain and adipose tissue. This decline in NAD+ has far-reaching consequences. It impairs mitochondrial function, weakens cellular repair processes, and diminishes the activity of sirtuins, enzymes that help regulate inflammation, stress responses, and metabolic efficiency. Sirtuins are NAD+ dependent, meaning their function is tightly linked to NAD+ availability. Thus, by elevating NAD+ levels through NMN supplementation, cells are better equipped to engage in protective metabolic processes, including autophagy. Autophagy, meaning self-eating, is a cellular mechanism that removes damaged organelles, misfolded proteins, and accumulated waste. In youthful tissues, this process operates efficiently, ensuring that cells remain clean, functional, and metabolically responsive. But with age, autophagy becomes less active, contributing to cellular dysfunction and the accumulation of metabolic stress. This impairment is believed to play a key role in insulin resistance, fatty liver disease, neurodegeneration, and muscle atrophy, all hallmarks of aging. Restoring autophagy through NMN-induced NAD+ elevation could be a central strategy in slowing or even reversing these metabolic impairments. Evidence from both animal studies and early human trials suggests that NMN can reinvigorate autophagic activity. Increased NAD+ appears to activate SIRT1, one of the most extensively studied sirtuins, which in turn deacetylates key autophagy-related proteins such as LC3 and ATG5, promoting their function. This SIRT1 dependent activation of autophagy is linked with improved mitochondrial health and more efficient fuel utilization in tissues like liver, heart, and skeletal muscle. Importantly, these effects translate into measurable metabolic improvements, such as enhanced glucose tolerance, increased insulin sensitivity, reduced visceral fat, and better endurance, outcomes that matter profoundly for aging populations. Moreover, NMN's benefits do not seem to be limited to one or two organ systems. In aged mice, NMN supplementation has been shown to improve mitochondrial function in the brain, reduce neuroinflammation, and even enhance cognition, suggesting a systemic reactivation of youthful cellular dynamics. In muscle, NMN helps preserve strength and energy expenditure by boosting mitochondrial turnover, a process closely tied to autophagy. In adipose tissue, NMN appears to influence the remodeling of white fat into a more metabolically active beige phenotype, which helps burn rather than store energy. The potential for NMN to serve as a holistic metabolic rejuvenator is also reinforced by its apparent safety and tolerability. In small-scale human studies, daily oral NMN doses ranging from 250 to 500 milligrams have been well tolerated, with no serious adverse events reported. Participants showed increased NAD+ levels in blood and improvements in markers of vascular and metabolic health. While larger and longer-term trials are still needed, the early signals are promising and suggest NMN could become an important component of preventive aging medicine. Importantly, NMN's action is not about forcing the body into artificial overdrive. Rather, it seems to restore the body's natural rhythms, especially autophagic cycles, that have been eroded by time, stress, and nutrient excess. By helping cells regain their ability to clean house and recycle waste, NMN may reduce the biological noise that accumulates with age and interferes with metabolic harmony. This doesn't mean NMN is a magic bullet or a standalone solution. Its effects are likely to be strongest when paired with lifestyle strategies that also support NAD+ and autophagy, such as intermittent fasting, regular exercise, and a diet low in ultra-processed foods. But as a daily supplement, NMN offers a potentially powerful ally in maintaining vitality and metabolic balance during the later decades of life. In conclusion, NMN represents a bright spot in the ongoing search for strategies to mitigate aging-related metabolic decline. Through its capacity to boost NAD+ levels, it supports autophagy, a crucial cellular process that repairs and renews tissues, and thereby helps preserve the metabolic resilience that defines youth. While more research is needed to determine the full extent of its benefits in humans, NMN's mechanism is grounded in well-established biology, and its early results inspire optimism. As part of a broader lifestyle approach, NMN supplementation may help aging individuals not only extend their lifespan but also enhance their health span, the period of life spent in good health and high function.